This video is about how to factor a trinomial of the form ax squared plus bx plus c with the product sum method, specifically when a is equal to 1. And when I say a equals 1, I mean this a in this form, which would be really just the leading coefficient of the polynomial. So here's an example where this fits. If you can tell, this a value would be showing up in front of the x squared, except you see nothing, which means you could sneak a 1 in there, or it's implied that there's a 1 there. And everything else is in descending order, just like this form. And so a great first step would be to identify what a, b, and c are. So a, as we just said, is 1. B is the coefficient of the middle term, which is -7. Always got to include the sign with the number. And C is the number 12, positive 12. Now the product sum method works like this. The product is equal to A times C. So in this case, 1 times 12, which is 12. And the sum is equal to the B value, which is -7 here. And now we play a little game where we have to find two numbers whose product is 12 and whose sum is -7. Now, there's no real magic trick to make these two numbers appear. It is a little guess and check sometimes. But for these numbers, it's not too hard to see that -4 and -3 are two numbers such that when you multiply them together, you get positive 12, and when you add them, you get -7. Now, in the case when a is 1, which is obviously where we are right now, the final step is simply this. Put down parentheses to create two binomials, your main variable x in the front of each, and then your two product sum numbers, -4 and -3, in any order, in with the x's, and that's in factored form. Now we'll do a couple other examples to show some other variations. Take this example, -a squared minus 2a plus 15. Now in this case, it may seem at first that a is not 1, and when I say a, I'm referring to this, the leading coefficient, the a up, in this form up here. So obviously a is our variable, but the a value would be the coefficient, the leading coefficient. In this case, it's -1. So you might say, well, wait a minute, it doesn't really fit the case where it equals 1, positive 1. That could be true. However, if there is simply a -1 in front, we can do a quick fix by factoring out a -1 from the entire trinomial. In this case, that would leave us with a squared plus 2a minus 15. So factoring a negative out changes all the signs, and now inside the parentheses, we do have a trinomial whose leading coefficient is 1. And so if we break out the a, b, and c values, referring to the a, b, and c up in this form, the leading coefficient is 1, the middle coefficient is positive 2, and the last one is -15. Okay, so again, I'm using the coefficients of this polynomial, not the original one. I've already factored out the -1. Well, the product sum method works the same way here. Product is a times c, which would be -15. The sum is b, which is just 2. And the two numbers that work, meaning they multiply to -15 and they add to 2, would have to be positive 5 and -3. So once again, since a is 1, this is the simpler method where we break this into two binomials. The -1 has to remain in front. We factored that out in the beginning. And now each of these product sum numbers is going to be written in with the main variable a, so a positive 5 and a -3, and this is now in factored form. The -1, which you could just put a negative sign altogether, must stay out front in order to be fully representing the original expression. And lastly, I'll do another now trinomial. In this case, however, there's a little more to do. Let's say it's x cubed minus 60xy squared plus 7x squared y. Now, this one, at first glance, looks much more complicated, and it is. However, we must remember the first step in any factoring problem is to factor out a greatest common factor other than 1. In this case, that would be x. There is an x factor in each of these terms. So if I simply factor an x out from everything, I'll have x squared minus 60y squared plus 7xy. Now, this is also different from previous ones in that now we have two different variables, x and y. And you might wonder, how can we put this in descending order of powers to match this ax squared plus bx plus c form if this y is here now? And here's how we can think about this. We can just imagine the x as our main variable, meaning I want to write it in descending order of powers concerning x, the variable x. So to do that, what I'm going to do is rewrite so that this is now x squared, and then the single x term would be this plus 7xy, and then there's no x in this term, so minus 60y squared. Okay, so once again, this is now in descending order of powers if you're really talking about x. And the best way to handle this is to just designate x as the main variable. Now the product sum is going to work the same way as it did before. We want to find out what a, b, and c are. And in this case, a is a leading coefficient, which is 1 inside this bracket here. Okay, so it fits the case where a is 1. B is going to be whatever was in front of, or more specifically, being multiplied to the middle variable x. So in this case, it's not just plus 7, it's also this y that is being multiplied by the x. So we're going to say 7y is the b value, everything surrounding that x variable. And then the c value, again, originally was just the term on the end, so this time that would be the entire negative 60y squared. Now the product and sum still work the same way. The product is a times c, which for us will be negative 60y squared, and the sum is 7y. Now it can be confusing to notice these y's here, but ignore them for a minute and just consider the numbers. The same product sum game. We're looking for two numbers whose product is negative 60 and whose sum is positive 7. Well, those two numbers happen to be 12 and negative 5. Problem is, 12 times negative 5 is negative 60, not negative 60y squared, and similarly the sum is 7, not 7y. So to fix these two terms so that the y's are included, all we have to do is add a y to each of them. And now it works. 12y times negative 5y is negative 60y squared, and if you add these two like terms, you get 7y. So we're going to follow the same process we did to finish last time, which is keep the factored part out front. In this case, it's an x. And we can actually just use parentheses now. We want to make two binomials with our main variable in front, that would be x and x, and then our two product sum terms that we found now on the end, which would be plus 12y and minus 5y. And so there we have it, the fully factored form of that original trinomial. And there are several examples of factoring a trinomial with the product sum method where a equals 1.